Okay, so I'll be covering the sin cos tan of the 803, the trigonometry stuff. So sin cos tan, what are they? They are actually just the ratios between the sides of a triangle. As you can see in here, sin is just opposite over hypotenuse, which if you can think about it other way, it's just the ratio of the opposite to the hypotenuse, because whatever over what is just technically the ratio. So since I will be saying sin cos tan a lot, I'll just use the word SCT. It's just the initials of sin cos and tan to explain it like faster and quicker. So when SCT is used as a standalone value, like a standalone word or something, or like a phrase in a question, it's actually just the like its true definition. It's just the ratio between the triangle sides. So if it's asking like if it tells you sin equals what over what, then you can assume that this value is the opposite and this value is the hypotenuse, right? You can just assume that. But when SCT is paired up with a degree value right next to it, it refers to the set value of an angle's SCT containing that value. That is a very confusing statement, but I'll explain. Say, for example, sin 45 degrees. This is what I meant by when paired up with a degree value. Sin 45 degrees equals just a random example, sin 37 over 42. In this case, what it means is these are still the opposite and the hypotenuse value, right? But it does not matter how different the sides, the opposite and the hypotenuse of the question's lines are. It's always going to be 37 over 42, because the sin of the degree is already defined. And okay, I'll explain this in another term. So okay, say the sin value of 30 degrees were to be 1 over 2. That would basically mean that any diagram containing a 30-degree angle, right, would any triangle with the 30 degree on it would have their opposites being 1 and their, let's say this is the hypotenuse, being 2. This is definite, because the sin of a degree is just an angle. It's infinite. It's like the lines can go on forever, but the angle will remain the same. So the values are technically always the same. I can explain this further if you don't understand. So this is an example question where we're finding A. We have the hypotenuse, which is, let's just call C, and we have 6, which we can call B. So we can basically just use the Pythagoras theorem to find it. In this scenario, I found it to be the square root of 85. And so after you found the value, A being square root of 85, you can then start finding the SCT if the question were to ask for it. As you can see, these are my answers. And yeah, this covers the basic of SCT. For the rule of why the SCT of a certain degree is a definite and it's a defined value, that means for any diagram or question that is mathematically correct and up to scale, their values would not change if the lines, the sides that the SCT refers to, say if sin, it will be referring to opposite and hypotenuse. Its opposite and hypotenuse value would not change in a ratio compared to the defined value you already know. You can use a calculator to prove this theory. And that's basically it.